there is a big difference between what 3ds Max does in particle flow or with the legacy particles when using force space swaps. The force space swap provides an acceleration to the particle. That means you have a particle with a position and a velocity, which in the beginning might be 0 or might be set to some value, and then the force comes and accelerates that particle, making its velocity bigger, and then the particle integrates to the next frame. That means it moves along that velocity to a new position, and then a force comes again and increases that velocity again, and so on. That means if you apply a force to a particle, the particle gets faster and faster, which is typical, for example, for gravity. If you're applying gravity to an object, it will get faster and faster until it reaches terminal velocity, because the drag of the environment, if it's not in a vacuum, starts acting in the opposite direction, and then it reaches a velocity that it cannot get bigger. But in particle flow, if you don't add a drag force, your particles will get faster and faster over time. This is not the same with Stoke. It actually takes that value from the space swap and uses it as a velocity directly. That means particles are moving with the speed of the medium around them and don't get any faster. Pretty much all the space swaps in Max can be used except for path follow, which is a special case that works only on legacy Max particles, and the drag, which actually reduces the velocity value of the particles and doesn't really accelerate them. So it really makes little sense as a field. But let's switch to 3ds Max, to the user interface, and take a quick look at some examples. For example, let's create quickly a geosphere anywhere in the scene, but I'll create it in the center. I'll make it the size of around 5 or something like that. And I'm going to create a simple wind. I'll create this wind here. I'm going to make it spherical, and I'll move it to the origin. So it's kind of aligned to where the sphere is. That means it will be blowing particles emitted from the sphere in all possible directions. Now, it's very important to set good settings for this wind. I'm going to add a lot of turbulence, so turbulence of 1, frequency of 0.01, and a scale of 0.05. Those are kind of magic numbers for a typical setup in 3ds Max, which I learned years ago from Brandon Davis at one of the SIGGRAPH masterclasses. It's strange that Max doesn't ship with those settings as defaults, but the frequency is normally set too high and you don't really get any beautiful motion, but we're trying to create beautiful motion, so let's see how that will work. I'm going to select both objects, and I have customized my user interface with 2 macro scripts that ship with Stoke. The first one creates Stoke objects, and the second one is the partitioning tool. Let's look at the creation tool. You can generally go and create from the geometry tab, go to the think box, find the Stoke object here, click, and so on. But instead of doing all this, you can just select the object in the scene that you want to use, click that icon, click in the scene. This will create a Stoke, and not only that, it will add the geometry object as a distribution object, and the logical, in this case, the velocity source, the wind space swap, as a velocity field. Pretty much everything is ready to go, and all I have to do is hit the simulate button, and it will simulate some animation of 100 particles emitted per frame, or 10,000 particles on the last frame. And if I start moving the time slider, I'll see those particles moving around. I'll switch them to velocities, and now you see that these particles are following the force lines of the turbulence field that I created. If I want to visualize them a little bit better, it's very easy to go to this geometry source, and we will see that we are currently emitting from the surface, from all possible faces. We don't even look at selection or anything. We just say, okay, emit from the whole surface, and I can easily check the checkbox that says texture coordinates. I want the texture coordinates to be acquired during the emission. And the interesting thing about Stoke is this operation, I can check all these checkboxes here. This pretty much has no effect on performance, which is not exactly the same in particle flow, where just using the mapping object operator to get some UVs from a nearby object might take a while. So I'll check this option, and I'm going to simulate again. And this time, simulation takes 1.4 to 7 was the total time. And if I go and switch the color to the texture coordinate channel. Let's see if we acquired it. Yes, we have it now. And we're getting, since the texture coordinates of a sphere have a W value of about 0.6 for some reason, we're getting the U and W, U and V are actually obviously changing, and the W is constant, so it gives it a little bit of a bluish color. If I want to create more particles, I can just click here and say, okay, I want to emit, instead of 100 particles, I'm going to emit 1,000 particles or 10,000 particles. Let's try 10,000 particles, which will produce 1 million particles on the last frame. And during the simulation, I could theoretically also preview how the simulation is going. So I can say preview every 5th frame. I want to watch what is going on. Now I start simulating and see how my particles are getting more and more. And at any point, I can hit the stop button and say, okay, good, that looks like it's probably too many particles, so I'm going to go one step back and create 1,000 per frame, so 100,000 on the last frame. I can hit the simulate button again, and it will reset and start from the beginning, update on every 5th frame, and now I'm getting a slightly different distribution. I mean, it's the same distribution, but a different count, so I'm getting more particles on the last frame. This will, of course, take a little bit longer, pretty much almost 10 times longer, because I had more particles to simulate. And of course, I can change the number of particles that are being displayed. I can show only 1%, or I can show 10%. This is pretty much, since all the particles in Stoke have an ID channel, it reduces the count as every end by ID. That means particles don't flicker in and out of existence. It's always the same particle that has been drawn, which is really nice. And you'll notice that we have a memory cache and also a button that says I want to save data to disk. What we're currently doing is, in the process of simulation, we are caching all the particles in memory, and I'm playing back from memory right now. And in addition, PRT files are being saved to disk. I can click this plus button here, and a new PRT loader will be created based on the data that's on disk. And right now it's loading 10%. I'm going to load 100%. So here you see all the 100% that we simulated are already on disk. And if I would disable that stock or delete it, that data is already captured, and it's ready to be used, reused in other scenes, and so on. So Stoke is using the PRT format for caching. I can go and explore the output path and actually see the list of all the files that were saved. And in addition, that is caching those PRTs, they are kind of the end output. So if I don't want to render the stock, but I want to render an actual PRT loader and apply all the deformations and all the other modifiers that can be added to it, I can do that as usual using the Kriktor tools. Another thing that is kind of interesting is I could go and simulate very few particles. So let's switch here to 100%. I'm going to switch to only 10 particles per frame. And I'm going to simulate. I'm not even going to save that to disk. I'll simulate just in memory. And I got a very low resolution version of this animation that I had. It's interesting to mention that in addition to all the other particle sources that Stoke supports Stoke as a particle source. So in this case, what I could do is, okay, I'm going to emit from that same sphere as before, the geosphere, and I'm going to use Stoke as a field, and I'll click and create a second Stoke. Now this second Stoke will be using the geosphere. I'll remove the Stoke as a possible emitter because it could emit also from its particles. I'll be emitting again from the surface. I'll still be capturing those texture coordinates and everything, but I'll be creating a lot more particles, let's say 1,000, using the animation of the first Stoke. That means I'll be resampling one particle system with another particle system. Let's hit simulate here and see what will happen. This was a little bit because it was on the last frame, it showed an interpolation of the previous frames. So this is a little bit low quality or very blurred because I'm dumping the stock on a grid with a size of 10 units, which is big. This is pretty much the size of a square on the grid. I can go with a much better quality. Like, let's see, something is happening there. Let's try 5 and simulate again and see if there will be a better quality. Yes, we start capturing more detail. and I can switch once again this to texture coords and this to velocity display. And now we're seeing particles that are from the second stalk following the particles of the first stalk, which I'm going to switch to just show the color. So we see the orange dots there. We're following those orange dots, and we're getting clumps of particles around each of the dots because we are following verbatim whatever is the value in the grid that that particle is put in. But we have a second option here, yet another option in the velocity field, which says create fluid motion. And what this does is it takes the information, the whole velocity field, from the particles that were encoded from the previous stalk, and it removes the divergence. That means it makes sure that at any point in space, the amount of data that is coming in and is going out is always the same. That means this is uncompressible fluid, and if I simulate this, the motion will be slightly different. And now we start seeing a very different type of motion. It's losing a little bit of detail because we are reprocessing the whole grid, and the result is that we are capturing some fine details here and there, but we're not getting some of the more of the larger scale motion. What we can do to avoid this is I can switch the velocity field to use multiple sources, each one with its own parameters. And when I uncheck this option, use global grid settings, each one of the sources will have its own setting. So one will have a setting of 5 and will be using the fluid motion. And I'll scale the influence to 0.5, so only half of the velocity of my particles will be coming from this. And I'm going to pick the same stalk once again, the stalk 0.1 from before. I'm going to set it to also 0.5, but this one will be using a size of 10. So I'm applying the velocity twice. Half of it will be using large scale voxels, and the other half will be using small scale voxels. And both of them will be trying to do fluid motion. So let's see what the result will be. Will probably be different on the last frame. We are capturing a little bit more detail, and I can continue here and say, okay, on this guy here, I can go even with 20, which will make it very reduced, very blurred. And the smaller one is capturing the detail. I should probably increase this one to, let's say, 0.8 and keep the other one to a little bit less, and try this. And each time I do this, the result is slightly different. Obviously, I can probably go with 10 and pretty much full force here and just add some detail from the other one, or disable completely the fluid motion in order to get different results. Now, we are not really following the original particles verbatim, but we're creating swirls and new motion within a grid as uncompressible fluid, and this creates completely new effects that have a more of a fluid look without actually running a fluid simulation. I will go a step back and mention Ember in the beginning. Back last year at SIGGRAPH, we were showing one demo, and this is actually the inspiration of Stoke, how we came to actually developing Stoke and why we did that. What you're seeing here is I'm comparing 1,000 particles emitted by particle flow to 100,000 particles which were resimulated using Ember, and a very similar approach to what we're doing in Stoke, basically taking the velocities of the original particle simulation, which is this on the left side. I'm not really sure if the webinar software will be updating fast enough, but we're getting very few particles here moving under the influence of a little bit of a turbulent wind. And if I compare this with the result from Ember, I'm getting frames that look more like fire. And this is exactly what Stoke actually does. It takes, in this case, very few particles, applies some fluid motion rules, and creates hundreds of thousands of particles that move under the influence of these other particles. But if I would show you inside of 3ds Max the scene that created, the Ember scene that actually created this simulation, you understand why Stoke was such a good idea. This is the scene that contains the, it contains two particle flows. One particle flow is driving the original particles, the yellow stuff, and the orange particles are the particles that are following behind, showing only a fraction of them. But the actual setup in Ember looked like this. So you had to wire some logic there to read data and apply it to velocity not vector over time. And then inside of particle flow, you had to create two systems, where the second system is using Ember follow to read those velocities and not vector particles. And that's just too much setup to get this effect. And using the same particle system and just clicking and creating a Stoke system creates exactly the same thing.